Next up, we have Jason Belk, who's also with Network to Code as a trainer, instructor, and engineer. I'll take a slight step back and kind of really talk through some of the things that we've been discussing and mentioning over the past couple hours, different types of APIs, data models, talk about what they are, and how they apply to network automation. So we'll let Jason get set up, but just to kind of repeat and kill another 30 seconds. Right, there are a lot of different platforms that exist today in the network automation space. There's different API types that run over SSH, run over HTTP, different modeling languages. We hear Yang quite a bit. We hear about a lot of different tool sets that exist to consume different APIs. Right, so this next session is going to really lower that barrier, continue to say what Matt's talking about, lowering that barrier, and really make sure we level set on a lot of these terms and technologies that we'll continue to hear more about the next couple hours and into tomorrow as well.
Well, welcome to the new Network Engineers CLI. I'm Jason Belk. And a little bit about me first. I have a background in Cisco IT. I was helping operate Cisco's production network for campus and branch, doing wireless, LAN, all that kind of fun stuff. So I can really sympathize with everybody who's trying to get up to speed on automation, but still closing tickets, doing new deployments. It's a lot of work, but it also helps to have that management support, giving you the time to do it, but it still takes nights and weekends sometimes to really get up to speed. So I'm hoping this presentation can help provide some of those initial building blocks for those of you starting to get some additional context, how to kind of lay of the land, so to speak. So I was in Cisco doing automation. I specialized in Cisco NSO, Ansible, Yang, and other Python APIs, and now joined Network to Code to help do training around Ansible, NSO, and other Python frameworks. And for me, I just enjoy also mentoring, helping optimize stuff, making more complex things more simple and accessible. You can see a picture of myself and my wife from last weekend. We were up in Reno, Nevada, for a wedding just on the other side of the state. We like to have a lot of fun together. So when it comes to automation, it's not just networking we're talking about. I know for me, living in the Silicon Valley, sitting in traffic, feeling the pain of not being able to be connected with other people because it takes an hour and a half of traffic just to get dinner with somebody, it'd be great to not have the stress of accidents and all these different components. So I'm really excited about the future of autonomous driving. But even for that, it's not going to be, we start with our steering wheel today, moving on to fully autonomous driving tomorrow. There's a progression, there's stages of where we're going from where we are today to having that fully autonomous vehicle. And I took this slide from seekingalpha.com. I felt it was like a helpful representation of this progression towards automation. And we can see that those same parallels in what we're seeing in the networking industry, where just in the automobile industry, things haven't changed for the past couple of decades. You just put your key in the ignition. You might have GPS now, but apart from that, not a lot has changed. In the same way on the networking side, we're still primarily managing our network devices with a command line interface, line by line. We might be starting to integrate some tools, but what we really need is to have this journey of automating our CLI, integrating APIs, and moving towards what some call intent-based networking, basically having your configuration, your operational state abstracted in a way so you're not worried about what specific commands you are. You're configuring policies, you're configuring services, and then you're having some type of operational state validation to make sure that you can close that loop and everything is operating as you intended. So when we're talking about the CLI versus the API, it's good to level set and just remind us that the CLI is meant for humans. It's built for humans. It's really easy for humans to understand the context. When you're looking at the command line interface, you have your sequential steps that helps you remember when you're making configuration commands or want to quickly look up some show output. So the CLI is just really easy to read, but it's actually kind of cumbersome and sometimes inconsistent to parse out. So when we're trying to, I know Kirk Byers with NetMiko and other people with Napalm have really felt this pain of when vendors or different platforms, even between releases, change their output. It can make things very stressful. And that's not to say APIs is silver bullet, but on the other hand, it helps us have a consistent interface and being able to have keys and values and all this structure to it, where from the CLI side, we as humans can intuitively pick up things based on our training and understand what's going on. But it's hard for those machines to pick up those contextual clues because you really need to explicitly say the relationships between the different components of your data, where the API has all those relationships explicitly laid out, even if it's harder for us as humans to read. So So for today, this is just the lay of the land of where we're going to go. We're going to start with talking about some common network APIs, talking about how they're encoded, looking at some data models, and then wrapping up with some automation use case applications. So the two most common network API protocols is not an exhaustive list, but just meant to cover some of the basics is NETCONF and RESTCONF, and also alternatively REST API. So NETCONF is not new. This is IETF RFC from 2006 using XML encoded data. And I think the really key thing to remember here is that we're using SSH for NETCONF. We're using the same protocol that we're all used to for managing our network devices, but now we're using the API. I know for me, back when I was at Cisco IT, having HTTP servers on our network devices was not something InfoSec was really keen about. So it helps to have, even if we're using a different port, still use SSH to manage our network devices. And it's also connection oriented in that we're having this ongoing conversation, talking to the devices. We're issuing remote procedural calls saying, I want to get information, I want to edit information, I want to update or delete information. And it also provides, regardless of the vendor, because it's part of how the NETCONF API protocol is defined, that we can have candidate configuration, similar to what you might see in Junos, where you can say, this is what I want to have as my intended config, and then if anything happens, roll back to the previous version. So you can separate your running config from your candidate configuration. That's part of, if a vendor supports that API, which as far as I can see, Cisco, Juniper, and Arista all support NETCONF at this point, depending on the platform. So REST and RESTCONF. REST APIs are very common within the software development world for managing HTTP-based APIs. So you have different applications, but in our situation here, we're talking about network devices. So you can manage those network devices over HTTPS, either using XML or JSON as the encoding format. And the important thing to remember here is that you're having stateless conversations. So in difference to NETCONF, where we're having this ongoing connection with SSH for REST and RESTCONF, you're going to issue a request, say, I want to get this piece of information. Okay, now I have a new request. And so you're going to have client-server model where you're continuing to grab the information and make changes. But the neat thing about using RESTCONF and REST APIs is that you're able to reuse software development tooling that's industry standard across the board. So you can think about all those sexy memes you might see on Twitter about, oh, we have all these tools for JavaScript and different things, but for network engineers, we're still kind of building out those different tool sets, but simply for using RESTCONF and REST APIs, you're able to reuse a lot of that industry standard tooling. So I took this from Cisco because I thought they did a good job of visualizing how both NETCONF and RESTCONF are interacting with the network device. So on the left-hand side, we see this application that could be C, Java, probably most likely for most of us Python. And on the right-hand side, we have a network device visualized with a config database, but it could just also be grabbing operational data too. And so we're going to be talking to that network device through some type of API, whether that's SSH as the transport, using XML as encoding for NETCONF, creating, reading, updating, deleting information from maybe BGP, VXLAN, different pieces of information, or for RESTCONF, doing something similar across the same data set, now using HTTPS to talk to our network device. So when we're talking about REST, we cover a little bit more about the specifics because it is so common within software development, application development in general. So if you think about browsers, when you type in a URL, such as say networktocode.com, which you all should make your new default homepage, you can then put slashes to say, I want to go /blog, /Jason Edelman's new blog, and that will say this is the specific resource that I want to get to, but you have to start at the top of the hierarchy, work your way down. With REST, we're doing the same thing, where you'd have maybe a network device or an application that has the top of a hierarchy. This is the root, so to speak, of the application. And then from there, we're going to go down different components piece by piece. Okay, we're going to go to interfaces. Okay, we're going to look at interface 3. Okay, we're going to look at that interface's Ethernet 3's IP address. So REST has this hierarchy where we're using HTTP and different HTTP verbs to say, based on this particular location within the hierarchy, I'm going to either create, read, or update, or delete information. And then you'll have maybe some type of body where you say, this is the information I want to have updated, and then headers and authentication to make everything work. So within REST, the main HTTP verbs that you're going to be concerned with, we have some examples here in the orange, how they correlates to network devices. So you have get, post, put, patch, and delete. And when I'm teaching this in our network code trainings, I like, because you have post, put, patch, they all kind of sound the same, I like to use the dodgeball reference, so they say dick, dodge, I don't know. Because they all kind of sound the same, but there are some distinctions between the two, between the three. So for HTTP verbs, we have that same location. Say we're looking at interface gigabit Ethernet 3. If we want to just get the information of running configuration or get some operational data, maybe drops, that would be get. Similar to what you'd see in a show command. For post, that'd be creating something new that wasn't there before. So maybe you want to create a new loopback. You can then use post against the location of where you want that loopback within the structure of the data. Or maybe you want to replace the entire configuration for a certain portion of your configuration. And with that, you would use put to update or replace some pieces of information. And then patch would be similar to what you might see in a merge command, where you have some existing configuration, you want to overwrite the new with the old and leave the existing where it's not being touched. And I think delete is pretty self-explanatory. So now we've talked about NETCONF and RESTCONF, we talked about some of the transport protocols, and all of these also use some type of data encoding format with XML and JSON. But why do we even need data encoding to begin with? Because there needs to be some type of structure between our systems. Because if we're talking conversationally, you're able to pick up contextual clues, but machines need to have all those contextual clues explicitly laid out for them. So what we have here is interface configuration that I think for most of us should be able to pick up exactly what's going on. We see the relationships between the data, we have some interface running configuration data, IP address, subnet, and we have some indentation, that's formatting. That's not defining the relationships between the different components of the data. So if a machine is going to look at that, you might be able to build some type of parsing engine that says, if it's indented over, this belongs to the hierarchy, but the inherent relationships of knowing this component is related to this other component is not explicitly laid out for us. So this is where we would use JavaScript object notation, JSON, or extensible markup language with XML. And these are interchangeable, so it's not like you have to type one and then retype the other. And you wouldn't actually retype this either. You'd have some type of API call where you're grabbing the information and then editing it on your own. Or maybe you have some type of parsing engine that takes raw text and then converts it into a structured data format for you, which is more tedious, but sometimes that's what you have to do. So what we have here is some information for a single interface, gigabit Ethernet. You can see the name is 1. On the JSON side it says quotes name, :1, so we're talking about gigabit Ethernet 1. And we see there's a parent hierarchy, so all of these relationships between the different components of data, if this piece belongs to the other piece that's a child of this other component, helps explain to our machine when we're building out our scripts and we're building out different applications, how all the different components fit together. Well, now that we have some data encoding formats, we also want to have a way of describing our data and having a data modeling language. So data models are a way of describing the constraints of our set of data. It's not the data itself. So if you remember back to the previous slide for JSON XML, we were saying this is the actual data for my network device. Data models, on the other hand, are not storing any data on their own. So you can see on the right-hand side, I see C3850, VLAN 10, that's the actual data. The data model would be on the left, we say VLAN ID. A VLAN is an integer between 1 and 4096. Or the VLAN name is a string between 1 and a certain number of characters. Or maybe the VLAN state is either there, present, working, or it's shut down. So I think for us, we pick up these contextual clues intuitively when we're learning the protocols, when we're learning the command line syntax. But it helps a lot for our application development to have all of these constraints identified, because there are software development tools we can then leverage to be able to dynamically generate different pieces of data, and it just saves us a lot of time in the long run. In addition to saving us time when we're trying to input data, when you have these constraints in place, you can stop it going in tracks. So if somebody typoed and said, I want to have a VLAN number 10A, and it has to be an integer between 1 and 4096, rather than running through your full configuration pipeline, and then at the end, after 15 minutes of verifications, you get to the point and says, oh, no, we got a syntax error. And so having data models, having a way of describing your data and having those constraints in place early on in the process also helps be explicit, what many of us see implicitly if we're working with tools like Ansible, Salt, and the other tools out there. We're working with, not with Python oftentimes, in very flexible data formats, and so it helps to have these data models in place to help us put the constraints early on in the process and work with these other API tools that enable us. So Yang is a data modeling language. So since we had the previous slide we were describing VLANs, you need to have some type of common syntactical way of describing the constraints so that we can reuse each other's different data models and be able to have tooling built around that. So Yang is a network-centric data modeling language. There are other data modeling languages out there, and those who've taken college classes, maybe for database design, schemas, things like that. But the neat thing about Yang is that there's lots of work that's been done by very bright people to talk about, okay, hey, let's build out some data models around interfaces, let's build some data models around routing. And so a lot of this work has already been done for you, and also the networking vendors themselves are implementing these data models into the APIs that they're exposing to us. So it's originally built for NetConf, and it's an IETF RFC, and also used by RESTCONF and other network APIs, such as like maybe gRPC. So it models both our configuration state and our operational state. So you can see an example. This is not actually Yang syntax, but just a summary of it using a tool, where we have interfaces, and you can see the indentation describing the parent-child relationship. Whether we have overall interfaces, and for a particular interface, we have a name, and that name has to be some type of string, some type of series of text, of numbers and words. And it has to be enabled, it has to be some type of type, whether that's gigabit, Ethernet, and so on. And then also we have some interface state information that we're going to describe the constraints. Maybe it's admin up, admin down, operational state as well. So Yang enables us to have this common language where we can describe the constraints of our data and then reuse it across our tooling, the ones we built ourselves, and also the ones that the vendors have provided to us. So when do we even use Yang? I came up with these two categories. I found that they were helpful summarization. Sometimes there was some confusion about, okay, we have Yang, so now what? So on the left-hand side, we have on-box Yang. So I would describe this as Yang data models that are on the network device being exposed through an API. Where you're interacting with the network device, you're saying, hey, NetConf, give me the interface for gig 3. And that Yang behind the scenes is then going to structure the data, provide necessary input validation, output formats to say that this is the data you're looking for. And it'll be the same way every time, assuming you're asking for the same format. So it's working behind the scenes. You don't touch the models. You can query the devices and say, hey, what models do you have available to you? That's part of what you have with NetConf. And it's also for streaming telemetry for operational data. On the other hand, we have off-box Yang. So this would be Yang models that we're using to structure data that's not actually currently running on the device. So this is super useful because we can use Yang to structure our configuration, say, to align with what the device model actually has on the other side. And this also helps us in terms of input validation, like I was talking about, for configuration management, making sure that you're not reinventing the wheel every time. It's like, okay, how do we build an interface list? How do we build a VLAN list? You know, you're able to reuse these industry standard, even vendor neutral models to represent your data. And some of the major tools we have out there, we have two vendor tools that I'm aware of. There's Cisco NSO, which uses Yang to model both the application services as well as the different CLI vendors to push to the devices. And new to Atom does something similar, including also streaming telemetry, and then also our own company recently released Network to Code Yangify and Rosetta, which basically take vendor CLI, use Python logic to then build your own custom data model from that, and I'll show you in a couple of slides an example. So for Yang data models, there's a couple of different families to be aware of. We have the industry standard vendor neutral ones, where they're describing the things you would probably see across any vendor. Say, interfaces, they're up, down, like we saw earlier, routing information, we're all using BGP. So this is really helpful because the network device on the other side, if it supports a vendor neutral model, you can talk to it, say, talk to your Cisco, talk to your Arista, talk to your Juniper, all with the same data model, all with the same inputs, if you're using these vendor neutral models, and then it will configure them all with your same inputs. So we're not having to bounce between different vendor CLIs. We're working with the API, and it will talk to it in a vendor-neutral data model that's then able on the device side to be able to make the configuration change and respond back if there's any errors or any output. And the two main categories for that are OpenConfig and IETF. IETF is the standards body one, moves a little slower, and OpenConfig is supported by major service provider enterprise vendors. So in the middle, we also have network vendor-specific models, and you can mix and match these. They're not just hard and fast categories, though you want to try to stick with one or two. So for network vendor-specific, that would be a network vendor-specific feature, say CDP. You know, it's not like you're going to have an industry standard CDP for Cisco's memory protocol. And then similarly for vendor platform-specific, things like power over Ethernet, stackable switches, different components that you'd only see on a switch or maybe a router or a firewall and things like that. So I know the OpenConfig one's a little hard to read, but I tried my best to format it so it'll fit on one slide. But what we're seeing here is I'm talking to the same network device over the API, in this case the Cisco CSR 1000V, asking for the same piece of information, but I'm using 3 different data models that the device supports to represent the same data. So we can see on the left we have OpenConfig, which has a lot of other information because they represent their interfaces and sub-interfaces and also include operational data in there. But all that to say is you can see some continuity, but you can also see some differences in the design decisions. So there's trade-offs for any data model you're going with. I'd say you tend to want to stick to more vendor neutral, but you also want to implement your vendor-specific features as well. You can see IETF in the middle, and then the Cisco vendor-specific output on the right. And you can see this is all for Gigabit Ethernet 3, and you can see the running configuration in that JSON format. So this would be an example of on-box Yang, where I didn't touch the Yang, I didn't do anything to it, I just sent an API call to the device, and in that API call I specified, hey, I want the output in a config format, hey, I want the output in IETF, I want the output in Cisco data format. And when the device got the request, it responded back with the appropriate format because it stores it in a way that it can represent that in whatever format that software supports. So now an example of off-box Yang. And this one's, if you're just getting started with Yang and APIs, it might be a little less intuitive, but I think it's still good to be aware of. So this is an example of the flow of our network to code Yangify open source Python project that you can go out there and check out yourself, where basically you can have on one hand your native configuration, you've done a show run, dumped into a file, and then you have the Yangify parsing engine, which you can check out on GitHub. And then you can leverage data models, these Yang models, OpenConfig, IETF, whichever one you want to choose. And so this allows you to take just raw vendor CLI that I think we're all going to have network devices for a long time to come. Hopefully not super long, but they're going to have only a CLI option, realistically. Because we all want APIs, but sometimes those devices in remote places are going to be harder to replace than others. And so this allows us to take our old CLI devices with a parsing engine, with these data models, and then automatically generate the abstracted variables of what is used to create that configuration. And so normally, if you're building your Ginger templates, if you're starting with Ansible, this is something you'd do by hand. You say, you look at the configuration, put in some Ginger variables, maybe create your YAML file based on your preference, or maybe use some advice. But this helps us adhere to a common data model, a common way of representing our network configuration in an abstracted way. And on the flip side, if you have that data model, you can then update the inputs and then use the Yangify translator to go the reverse direction with the standard inputs and then render the vendor CLI. And the other benefit of this is that it kind of gets you used to using Yang as a data model language, and also gets you used to how those different data models are formatted, so as your devices become more and more API enabled with newer devices on your network, you can then, it's not just point from 0 to 100, you're kind of working your way up to a place where you're including more input validation and other ways of structuring your data.
Question.
Yes?
Your last slide, is the line ID supposed to be flipped on purpose, or is that just a typo?
That was probably my typo.
Oh.
Yeah. Yeah, because I updated the slide to include YAML instead of JSON on it, because I thought it was a little easier to read.
Oh.
And the YAML just had reordered it.
I was just trying to show something weird happening.
No, that's so that the previous slide that Jason had put on our blog had in JSON in the correct order, I believe. And then I just updated to include YAML because I felt like it's on slides it's a little easier to follow. A good call. So what does this actually look like in terms of different vendor applications, different open source automation use cases? So I'm not going to go into detail on every one on the slide, and if I forgot somebody, it's not malice, just because these are the only ones I can find icons for that I knew of. And so what we have here is just a smattering of different options that when it comes to using APIs, automation, some of these different categories in terms of configuration management. Other ones are operational validations, such as Batfish, or source of truth for NetBox. And so what we have here is different open source options that you can get started freely, get going, start learning things. And on the vendor side, you also have different orchestrators and tool sets to help either create a configuration, do testing networks into pseudo, or verify the output, or have different workflow orchestration engines. So I think the key thing when you're looking at different vendor softwares and open source solutions is looking at your particular context and the trade-offs, where there's a trade-off for every design decision you're making, and you want to say, what vendors do we have on our network? What skills do we have? Do we have strong software developers? Are we investing in that direction? What's the price point? What's the return on investment? These different components that, for open source, definitely helps get you started, but you also want to look at the long-term vision of maybe a vendor solution, or whether that's Cisco, Juniper, Arista, or even a non-networking vendor solution might be a good fit for you as well. Because part of it too is not just the APIs themselves, but all of the ecosystem, the tooling, the workflow orchestration around what you're trying to accomplish, as we've seen in the demos earlier today with Jared, Darren, and other folks as well. So as we get towards the end here, I also wanted to just drive home that it's not just the network APIs, not just the data models, but they're also just the holistic operational model for your given business context, where you're probably going to have some type of organizational change, where you're going to want to have some type of tech lead, somebody with network automation experience, or somebody who's committed to learning that themselves and mentoring and bringing other people along the way. Like for me, I know in Cisco IT, at the time, the other senior leaders in the IT team that had been doing automation had left the company, and so I didn't have anybody to look up to. And so like when I was learning on my own, my management gave me space to learn that, taking trainings, trying out new things, hopefully not failing in production. And so, but the investment returned. So after I'd done that for a year and a half, it takes time to have the overwhelming learning speed. NRE Labs, if that was around, that would have helped a lot. DevNet's helped a lot, and so, as well as Jason Edmonds' book. But the key thing is having management that's supportive of it, where it's not just you, the rogues CLI person, rogue scripting person going out there and trying to do it yourself. You want to have management that says, yes, give it a try. Start small, don't break the whole network, but we want to see you actually growing in your skills in this area. And you're also going to need to see some business process changes as you're integrating more APIs into your network. It's not just about a lift and shift of, we did this thing the old way, now we just do it faster. It's like, well, maybe provisioning that VPN could be self-service. We don't need analysts to have requirements gathered for 3 weeks. We can have them go to a portal where, as long as they have budget, they might not be able to customize every bell and whistle, but they'll get it in an hour instead of 3 weeks. And so having those trade-offs and those economic incentives provided to your clients, or if you just try to do a lift and shift of the existing process without any type of negotiation and understanding your workflows, you're going to continue to hit hurdles. And so understanding your existing workflows, documenting all those dependencies, and where the time's going, how can we actually do this differently is really important too. And then overall, you want to have your open source vendor software combined into a configuration pipeline where you're managing configuration and then validating that all that output is coming to fruition. So finally, I just want to have some final lessons learned that, just as a word of wisdom, don't let the goal of end-to-end automation destroy your opportunity to make a difference right now. It can be so exciting to see success stories, but it can also be demotivating. Man, those guys, really famous company, they have SRE DevOps at the wazoo, and we're just barely going from Bash to Perl to Python. And so don't let those success stories get you down, but also don't be content with just staying where you are. You don't need to have some grand automation strategy, even though that is helpful, and our company does help do consulting services to help visualize that. It's about making that forward progress and understanding that you're going to gain momentum, and you're going to gain momentum, and as those successes get bigger and bigger, it's going to become easier and easier, even if you have that uphill difficulty at first. So you also want to integrate APIs and automation into your network architecture design process, where up until now, I feel like automation was kind of a second-class citizen, at least in my experience in a lot of different contexts, where it was like, okay, we have this new VXLAN, we have these new different components that we want to roll out, and then after they've already made all the decisions and bought the hardware and everything's just weeks away from being started, okay, we want to make sure to automate this deployment. And Okay, we'll try to figure out a way to make that work. And so the important thing is, early on in the design decision, architectural decision process, you want to have automation as that first-class citizen where management understands the value, and it might even affect your decision-making process. So it's like, yeah, it's going to reduce our speeds by 30% because we have to go to this other vendor or this other platform, but it's going to reduce our deployment times by 90%. So which is better, having inconsistent configuration that's hard to automate and requires 500 developers, or having, a much easier to work with platform? So another thing is to document your data model. So if you're going with IETF or OpenConfig, or you created your own, include those additional context and design decisions when you're making these decisions, because down the road you might forget. Like, I don't know how to pick that one. Okay, we'll just do this other thing. And it's easy to have the shiny new syndrome. Have the shiny new syndrome really go into effect, where you're always creating something new rather than reflecting on, okay, these are the design decisions we made, and maybe now we need to reevaluate these decisions. But at least we can have the additional context of our history to apply that to our current context. So, of course, you want to build and use different data models that are as vendor neutral as possible, especially since I think most of us are in multi-vendor environments. And of course, reinforcing what I said earlier, you want to design not just for the technical implementation of, I have this cool script, but how are people actually going to use it? So this is something, a pain point I felt personally when we created an iOS upgrader within IT, and we spent a ton of time, creating 15 different hardware platforms, testing in the lab, rolling out production, hundreds of devices, and we wanted our people who were contractors who were regularly doing these upgrades to use it, and it just never got adopted. I think going back to the conversations we had earlier in the day, if you have a new tool, they have to remember a new website, the login doesn't work all the time because RBAC and all these things going on, where you're trying to integrate your automation as much as possible. As you're using these APIs, use that to your advantage. Work with your InfoSec teams to have a place that's secure, but also actually currently close enough to what's doing the current workflow. So, and finally, you want to test your APIs in a lab mirror in production, because just like we see bugs in network software, you can get bugs in your APIs, and you want to catch those, not just assuming that just because it's an API it's magically perfect. People want to make mistakes, but you also don't want those mistakes to fail at scale. And so that's where testing all of that in the lab and having production equivalent hardware, software, ideally traffic and validation really comes to help make that a reality. Thank you. Any questions?
Yeah.
Yeah.
Did I kind of interpret that slide before correctly? And that works a little bit. Left, right, yeah, okay.
Sure.
Is it taking, so you're taking CLI, produce structured data?
Yes.
So you take that same data, modify it, add that. I can imagine a workflow where you use that sort of as your model for the structured data you need to produce, right? So if you pull something out of a source of truth somewhere. Yeah. Well, it's not going to be in a format that your network device cares about.
Yep.
Right? So you have to have a software there.
Yep.
It seems like this would be kind of an important part of that.
Yeah, for sure. So say you have your VLAN information in that box. You grab REST API. Here's the name of the device. Here's the VLAN information. Then you do a mapping between this is where my sources of truth are coming in, and this is the data model that we have to see.
I mean, this is like giving you a known, so presumably here, I've got an old iOS XE box that because of licensing constraints, I can't upgrade because we don't want to pay for support. So I can't talk anything. Exactly. But this is giving you
off box. Yeah. So this would be running on a server, your laptop for testing. You'd be running Python code. You can see the open source code. We're welcome for contributions. Where you're rendering the native CLI or taking that CLI and then abstracting that into a native and vice versa. And then however you want to get that to the box is your problem. You can copy and paste it. You can use Napalm. You can use Ansible. You can take a flash drive and drive over there. But it's the really exciting thing for me for this is that we're able to have using industry standard data models, because people have worked in IETF and OpenConfig and the vendors, I put a lot of thought and time into making these decisions. And so we're able to reuse those models, but Network Dakota has also produced our own models that are simplified, because some of those models can be not so intuitive when you're getting started.
Realistic. So you're using Yang there. I mean, it says OpenConfig Yang. So is that for sure definitely valid OpenConfig Yang that you could use on real device if you're talking?
Yeah. Yeah, if the device supports OpenConfig VLANs, then you'd use NETCONF or RESTCONF you wouldn't probably use the CLI in this case, but that's really the goal, is to have a consistent data model across how we're managing our CLI for the foreseeable future, and also those newer fancier API devices. Yeah.
What kind of adoption are you seeing for NETCONF and RESTCONF in real life?
I'd say it depends on which vendors the people primarily have. So I think it's one of those things that for Cisco and Arista, it's still relatively new. And I think people are just getting used to Ansible and Jinja. But yeah, I'd say for Juniper sides, it's much more common but you'd have to do a lot more legacy Cisco stuff out there that's not going to support it. And that's hopefully where this can help bridge that gap. And once they put in, the newer, fancier Cisco and Arista stuff, then they can use NetConf on there as well.
So if someone has a mix, let's say they mostly Cisco,
yeah,
and they've got a mix of legacy and new stuff.
Yeah.
Do you typically see them just choosing the lowest common denominator for everything, or do you usually see, let's use the new stuff where we can and the old stuff where we must?
Yeah, I would say it's mostly the lowest common denominator, unless you have like an executive who's really fired up about automation. So I'd say the credit to my Cisco IT manager before I left, their design decision, their case was to say, we have older stuff, just keep managing the CLI, automate as much as you can, but that's going to be end of life eventually, and then everything new is going to be managed with DNA Center and NSO and all these types of things. So it just depends on, I think, your management support and like your, I guess, like development resources. Because it's easier to make that transition, but I think with the lowest common denominator, because then you don't have to like learn Yang and all these new things as much. Yeah.
Well, but then something like this kind of helps
elevate
exactly.
Exactly, and that's part of our goal, apart from helping push the industry forward and using Yang, is helping bridge that gap where it's like, I'm not ready for that contract yet, we're not going to use it yet. But here, this is a stepping stone to get people used to using data models, but still using CLI.
A few points that I want to make on this too. A lot of the calls you're seeing, the goal here is we can leverage automation tooling, leveraging things like OpenConfig models represented in JSON or YAML. And then if we need to, translate it to commands. If we don't need to, pass that object out to the device. But to the question, what's being used, it's ironic, but I think I've seen more bugs in APIs than in the past couple of years than we've seen changes in spacing output and CLI output. So one could argue that SSH has been more predictable and stable than particular APIs that exist. And it is the reality, but it still is when you look at an install base at a given client, you do want to try to have some uniform ways to operate. And this is a step in the right. This is really new projects, right? Within the past couple of weeks, so it's still very early on. But in general, I'll say one example practically is when you look at even Ansible, gaining more traction in the networking space. A couple of years ago, there was a lot of Nexus modules for Ansible. You could do things like NXOS VLAN for VLANs, interfaces for interfaces, and so on. But then every other vendor, you have to change a template and build command sets. And so, a lot of our clients would forego using those modules and just Yangify everything because it was a common practice and it became like the way to automate. So you really always want to kind of consider pros, cons, and if you end up just big if-then conditional block to operate your network, it becomes harder. And at the end of the day, what you really want is for your tooling not to have to change if your device is changing the covers. Right? So ultimately, when you're making a configuration change in the future, regardless of how you're doing it, if you're operating the network through infrastructure as code and these types of principles, you're really you might be editing files or databases that generate configuration. And like that should never have to change, right? So if you do pick a model like a Yang-based model, going top down, translation to Junos to iOS to EOS, API or CLI, at the end of the day, becomes more of the mechanics of how, although we do want to get to using APIs at the end of the day.
Cool. I still have time for one more question. Anybody else? Yeah.
So like, what advice would you give, like so right now if we are using like singular APIs, right, for Cisco, Juniper, Cumulus, right, and if you want to move to like OpenConfig or something like that, like the shift is big, right? Would you suggest like just moving it over? Is there like a big adoption for that, or just continue using like the native Python for each of them?
So you're asking, you're using the
Yeah,
APIs?
I'm just asking like, yeah, so we have our like homegrown automation tool, right, for each of the vendors that we use. So people say that there's an option for OpenConfig, people are contributing, so like, should we move to a vendor agnostic model, or?
If you've already done it, you don't need to start over. But I'd say it would take more of like a dive. But if you already have a lot of work invested in having each vendor solution already worked out, you're still going to need some type of like orchestration layer or a way of coordinating that across them, whether that's people or processor.
Yeah, I think you definitely want to understand the APIs to see the value they bring.
Yeah.
At the end of the day, even if you don't use them today, understanding NETCONF and RESTCONF to see, the value of a good API to be able to, replace a section configuration or whatever it might be, and get the response code back. If you want to understand it, even though you might not use it day one because of an install base of 100 devices, maybe 20 or 30 of them support those protocols. Right, so you still want to understand what's possible to build it into your journey. Right, so I think from a learning perspective, it's important to understand sort of what a model is, how to use a model. Right, because a lot of tools, if you define YAML today for leveraging Salt or Puppet, a lot of these tools, you actually have an inferred model. You just define YAML VLAN 10. You just know in your head never to go above a certain VLAN ID. And so, understanding the concepts first and foremost of the strategy is important, and just experimenting, even though you might use it in production, is still really, really critical.